So like Tom's saying, traffic part HTTP is based on HTTP bit is based on WireMock. So thanks to Tom for the great tool. I recommend it on any occasion I can, online and both online and offline. We're contributing to WireMock as well. So thanks for the tool, Tom, and I don't know if any contributors are here as well. So thanks to the contributors as well. Thanks, guys. There we go. So thank you. But anyway, so what I wanted to talk today about is JMS service virtualization. So my name is Wojciech. I've been doing software development for more or less 10 years. And I wanted to, so I don't know who's in the room today, and I'm going to keep it quite basic from my point of view. But it's going to be basically an introduction to JMS service virtualization. And that's the key takeaway I would like you guys to have today, that if you haven't seen stuff like this yet, you're going to see an example of how it could look like, and we're going to go through an example how you could actually do it. And yeah, so that's my hopefully takeaway for you guys, that you're going to realize, all right, you might do that stuff actually for JMS as well. And another thing I wanted to assume is that we in here know more or less what test doubles are, service virtualization, mocking, stabbing, all those things, so that I don't have to go into the details, and we're just gonna keep it short and simple, dive straight into how we can do the JMS bit. So a quick JMS refresh to start with. So JMS is an asynchronous API for asynchronous communication. So if you're doing HTTP, you're going to send a request and you're going to synchronously wait for a response. HTTP 200, HTTP 404, but you're synchronously waiting for that response. What happens in JMS is if you're going to be talking to a server via JMS API, you're going to send a message, and that's basically it. So in JMS, there's two kind of modes of communication. The first one is point-to-point, which is a client is going to be sending a message, and the arrow points like shows how the message is sent, which direction the message goes. The client's going to be sending a message onto a queue, and then another client is going to be consuming messages off that queue. And I think worth pointing out is there's no time dependency between those events. So client 1 can send whenever, client 2 can consume whenever, and the queue is just going to be storing those in the meantime. And we got publisher, subscriber, so topics. A client is going to be publishing messages to a topic, and we're going to have one or more subscribers to the topic, and they're going to be consuming the messages from the topic. The difference here is that there is a time dependency, so you can only see the messages that have been published after you have subscribed. And one more quick look at from a different angle. So as I was saying, JMS is only an API, so we're going to have many implementations, for example, ActiveMQ, ABMQ, many other ones, and they're going to provide an API on top of an API you can use to call them, and via JMS provider is going to be a JMS API. So is everybody more or less with me so far? I'm worried that I'm like shooting, blind with the audience, and I don't know if I'm talking about something you more or less know what I'm talking about. All right, see nodding heads, cool. So let's have a look at a simple, in my opinion, but we'll see. I've been doing that for too long, probably. Example of recording a queue, and we're going to have a hypothetical situation where there's going to be two systems communicating, and they're going to be sending a request message and a response message, and we're going to see how we can do a record and replay. So this is a hypothetical situation which we see in real life, and you're going to have a system A that sends a request message to a broker. That's arrow number 1. Then system B is going to consume that message, arrow number 2, do some processing, and after a while it's going to send a response message, arrow number 3, to the response queue on the broker, and afterwards system A is going to consume that response message, arrow number 4. So this is a hypothetical example, but quite often happens in real life. So in order to record that, we're going to do something similar to HTTP, but a bit different. Proxy messages and record them in the meantime. So what we're going to have is the white stuff is from the previous slide, and we got this blue bit, the virtual service bit in the middle. So what's going to happen is System A is going to send a request message to the virtual service request queue. Then the message is going to be consumed by the virtual service, and the virtual service is going to say, I've got the request message, I'm going to remember that. Then the virtual service is going to forward the message to the request queue on the original production broker, sorry, the real broker. That's arrow number 3. Arrow number 4, the system B consumes that message, does some processing. After a while, it sends the response message, that's arrow number 5, to the response queue on the original broker. Arrow number 6, virtual service consumes that response messages, and it notices that, okay, I've had a request message, now I've got a response message. How about I create a mapping for those? So arrow number 7 creates a mapping for this type of request. I'm going to be producing these types of responses. That is what I have seen. And then it forwards the same message to the to the virtual service broker, which is arrow number 8. And then system A consumes that response message, arrow number 9. So once we've recorded something, we want to use it. So we're going to replay those messages and hence be able to test our system in isolation. So we got our system A, which is our system under test. That's the bit we're testing. And it's going to send a request message, arrow number 1, to the request queue, which is the virtual service. So sorry, the bits that's missing here was on the right, which is the real broker and system B. So those bits are missing. We're just using the virtual service infrastructure to test system A, the system under test. So system A sends a request message to the virtual service broker, to the request queue. Virtual service consumes it, looks at the mappings and matches it against something. It finds a match and creates a response message, that's arrow number 4, sends it to the response queue, and then system under test consumes that arrow number 5. So in this way, we are able to test our system A, system under test in isolation in this hypothetical example. So I wanted to have a look at an example of how we could do that with a tool, so it's not that dry. So this so far was, you can do it with any tool really. I wanted to have an, something that you can actually do at home if you wanted to, if it makes sense for you. So what we're going to do is use, we don't want to make it too complicated. So system A and system B, we don't want to create systems to demo this stuff. So I'm going to pretend to be those systems by using Hermes JMS. That's a tool that allows you to consume and send messages. So I'm pretending to be system A and system B. We're going to use ActiveMQ for the broker, and for the virtual service, we're going to use Traffic Parrot with an ActiveMQ instance running internally. So let's go ahead and look at that. So first of all, we need to start up those things. So, okay, this has, can you guys see that in the back? Large enough font? Cool. First of all, start Hermes. We got Hermes here. Then we're gonna start. I've got Traffic Parrot downloaded here, so I'm just gonna unzip it. There it is, it's unzipped. Go to the directory and start it up. Look at the logs just in case. It's a live demo, you never know. Yeah, everything seems fine. And then we're going to start the the local ActiveMQ instance. So we've got all of those things started up. Now what we want to do is wire up this recording. So what we're going to do is arrows 2 and 3. We're going to set up the recording so that the virtual service consumes stuff from an internal broker that it's set up and forwards it to the request queue on the original broker. So let's go ahead and do that. So I got Traffic Parrot here. There we go. JMS record. I'm going to start up an internal broker on port 1991. We're going to record the queue. And we're going to record from the internal broker, record queue, to local ActiveMQ in the same queue name. If you want to know how to configure these things, you just click this question mark and it's going to tell you how to do that. And then, so we got 2 and 3 and the virtual service internal broker done for now. Now we need to do 6 and 8, which is consumed from the local ActiveMQ instance and forward it to the internal broker. So let me do that. Forward to internal broker. Turn it on. Yeah, it started, all looks good. And we got the mappings and current recording session here. So we can start playing messages. So what I'm going to do is pretend to be system A using Hermes JMS and send a request message to the request queue. That's arrow number 1. Okay. Request queue, new message, payloads, let's say request 1. Okay, so now what we expect is the virtual service should have noticed the request message and it should be also forwarded to the request queue on the original broker. So let's have a look at that. Yeah, there we go. It's there on the current recording session, a request message and the text that we've just input. And we can use Hermes JMS to look at the local instance, which is this guy of ActiveMQ on the request queue, should have that message. Yes, there is request 1. So now I'm going to pretend to be system B, consume that message, and produce a response message. So I'm consuming this guy by deleting it and producing a message to the response queue. There we go. So what should have happened now is the virtual service should have noticed it and we should see something on the response queue in the virtual service broker. So let's have a look at that. Going back to this page, yeah, so we see a response message, RSP1, and we've got a mapping as well. So if you see something on the request queue, on a queue, request queue, and the request is equal to request 1, responds to this queue with this text message. So yeah, there was a recording. Now we can go to replaying and test our system, which is going to be me again. So we're assuming that I'm the system on the test actually, and I'm testing Hermes JMS basically. So we're going to replay the traffic that we've just recorded. So to do that, first of all, we need to start the replay. So I have already stopped this guy. So I'm going to replay. We're going to start the internal broker again. We're going to replay only queues, and it's internal to internal. There we go. And we're going to be replaying this mapping that we've got there. So again, go to Hermes JMS, start it up. Okay, so again, pretending to be system A, sending arrow number 1, sending the request message. That's the internal broker, so this guy. So what we should see now is something on the response queue on the local broker. And there it is the response that we have recorded. So one more thing we can do actually is, let's pretend to be system A and consume this guy by deleting it. But one more thing we can do is actually, just to show you that it's actually working, I can change this response to something else. Yes. Start up this guy again. Send a request message again, pretending to be system A. And now we expect something on the response queue, and there we go. That's the guy that we were expecting. So yeah, that's pretty much it. But just to reiterate, so we've recorded something, then we've replayed it, and as I was saying, that's a simple example, I'd hope. And this was about to give you, my point was that I wanted to give you an intro of how JMS service virtualization could look like, that you could do, for example, a record and replay. And if you want to, if you've got problems that service virtualization, stubbing, mocking, test doubles solve, and you want to do this kind of stuff on a larger scale, go ahead and research that. And yeah, so if there are any questions, I'm more than happy to take them. And also, I'm always happy to have a discussion and a chat. I'm always happy to learn what you guys think. As I know, Tom was inviting here guys that have been doing these kinds of things for a while. So I'd be curious, to have a chat with you guys later or now, and just to see what are your thoughts. Otherwise, you can always email me. All right.
Thank you.
Thank you.
Hi. Hi. You can hear me? Can everyone hear me? Yeah.
Yeah, it's just to record the answers.
Excuse me. I'm sorry. Basically, I just wanted to ask, presumably with your tool, can you do it programmatically so you can set up the
so you mean like in WireMock, for example, you have these stub for and those kinds of things that you'd use in the test. So, yes, the short answer is yes. The longer answer depends on what you mean programmatically.
So programmatically set up the mappings and enable you to before you run the test to set up your
so the short answer is yes, but we've got a few ways of there's a few ways you could programmatically set them up, and we implement one of those today. So shall we catch up afterwards?
Sure. Thank you.
But yeah, the short answer is yes.
I just wondered.
Sorry, do you want to grab the?
I've got a mic already. Sorry. I just wondered what would happen if the response was more than one message. So you're sort of making an assumption.
Yes. So this is making an assumption. This example is making an assumption, and right now, as you saw the GUI, right? Obviously, you already noticed that it's constrained to certain types of, patterns that you can actually virtualize, right? So that's a very valid point, and the answer is you take them case by case, basically. So this was a simple example. You can do much more with this.
You can see how you could build it out.
Yeah. So so the general thing is, how often do you see those? And it's always going back to this 80-20 thing. Do you need to actually virtualize that? Because you've got 10 APIs that you can do this way, and then one that you're going to spend 3 months of work needs to be done to virtualize it, but do you actually need it, etc., etc. So it's like the short answer is case by case basis. Well, very good observation, yeah.
I had kind of a specific question along those lines, which is what if the your system is not sort of request response in nature, if it's just essentially a stream of messages going from one endpoint to another. So you don't have the request as the trigger for a response message coming back. Yeah. So that goes to your testing infrastructure, right? So why would you need to virtualize something in that case? You wouldn't, right? This very simplistic example, you just send messages, so you only need to, the client. So there's nothing to go back. Hence, there's nothing that there's nothing you need to record, though. I mean, since if all you want to do is capture an existing scenario and then replay it without the real back-end service present, then I can see you wanting to do that. Even if if it's not a two-way conversation. Yeah, definitely. So so the thing is, so how we prioritize stuff is by the clients, obviously, right? What they need, and this is what we've seen so far, and but yeah, very, very valid scenario, and we just haven't seen it so far, probably often enough to just do that stuff.
A couple of questions. Do you have an API for verification as well, so you can?
So at the moment, no. So depends why you're asking. If you want to use it today, no. But I would want to go back and ask why would you like to do with this technology and what type of broker you are using, because there are already open source solutions, for example, for ActiveMQ, where you could do similar things, right? So my question would be to rephrase it and say which broker are you using, and whether you actually, why aren't you using that broker's tools that might already provide that functionality and they are open source. So yeah, that depends on the broker you have in mind.
The other, was there a correlation ID that let you map the request to the response towards incoming request?
So there's a few ways you can do it, right? What correlations is one of them, but depends on your specific case. Since it's asynchronous, there's so many, like everybody's probably already noticed. It's the scope of things you can do with this gets so much bigger that if you want to put it into a programmable interface or a GUI, it's going to grow very exponentially very fast. So sorry, I got lost. Where was I going? So what was the question?
Correlation IDs.
Oh yeah. So what we have seen people use and what they're fine with is just for the purpose of the recording, they just see what they expect is they set up this recording in a way that we just did, for example, and they don't need the correlation ID. Thank you.
Sorry, one more from me.
Definitely.
So as you've already alluded to, the sort of there's a kind of an explosion of possibilities in terms of the way an interaction can play out when you're doing things asynchronously. Far greater than within a synchronous context like HTTP. Obviously, even when you're doing HTTP, there are lots of false scenarios that you can simulate and that are worth simulating for testing. So I'm wondering, what do you commonly find yourself doing? In terms of fault simulation in asynchronous context, do you have a sort of I guess a selection of faults that come up often enough that they're kind of in your regularly used toolbox?
So you mean there's like protocol faults, there's faults on the application level, there's different type of faults, right? So obviously with this you can simulate right now application faults. It's just a different content in that message, but the protocol is fine. And at the moment nobody's requested yet protocol faults. So we don't have that today, but that's a valid point. So the roadmap here is to have something like WireMock, for example, but the kind of mindset for a tool that can be used very quickly, very easily, and that supports protocol faults as well. All right.
Okay. Thank you very much.
Thanks, guys. I hope it was useful.